Right, we'll start the session. So we have started the module number 1, that is the soil exploration in previous class. And in previous class, we have discussed in soil exploration, that is objectives and importance of the soil exploration. And in today's session, again, we'll continue with the soil exploration only. And we'll discuss about already I discussed the stages in site investigation, that is the site reconnaissance, preliminary site exploration and detailed site exploration, and preparation of a soil investigation report, how the report should be after investigating the site. And those things we have discussed in the previous class. So the continuation of this only. Today, again, I'm going to discuss about the geotechnical investigation, the same thing, but in detail. The just introduction part of this reconnaissance, preliminary investigations, and detailed investigations I have discussed in the previous class. So today also I am going to discuss the same thing. And in today's class, I am going to discuss about the reconnaissance, how it should be, and about the preliminary investigations. And the detailed investigations, I'll take it again the next session. So basically the geotechnical investigation, whenever you want to investigate the site or the subsurface exploration, as I explained the previous class, the subsurface exploration or the site investigation means obtaining the information about the subsurface conditions at the site of proposed construction. So that is what we call as a subsurface exploration or site investigations. So looking at this picture, so as I told in the previous class, the reconnaissance means it's just a site visit. It is the very first step of the subsurface exploration program, and which includes the that is a site visit as well as the study of maps and other relevant records. That is what we call as a reconnaissance. And the preliminary explorations are generally in the form of borings or test pits, and where these two datas, that is reconnaissance as well as the preliminary investigations, are not sufficient, then we go for the detailed investigations. This picture depicts how the person is looking into the site. He is getting the more information about the subsurface explorations. So we have to go for in detailed investigations about the site to get the more information about the site. So let us start the first one, the reconnaissance survey, how it will be. And generally a person who is in charge of the subsurface exploration or the geotechnical engineer makes a visit to the site for a careful visual inspection, and also you will be getting some of the information, what information he should get when he visit to the site. He should get, that is he should inspect or the inspection of the site and study of the topographical features. So he should visit to the site and he should study the topographical features about the site, and also study of maps and other relevant records he should get, and also collect details about the proposed construction. That means what structure he is going to construct. He should get all the details about that proposed constructions, and also collect already existing data, if data are existing already, means previously, and then examine for the soils and geological conditions. So you have to examine the soils and geological conditions. Then next comes the collect details required for economic designs, means how the cost can be reduced. You have to collect the details from the adjoining structures or already available data you can collect. Then helps in deciding a future program of site investigations. means whenever you visit and inspect the site, which will help for the future program of site investigation, and also it helps scope of the work. Then the methods of exploration to be adapted, and means what methods can be adapted to get the more information about the site, you will come to know by visiting the site. And also the types of samples to be taken, means by visiting the site you will come to know what type of samples I may required for getting the more information about the site, and also what laboratory tests to be conducted, or in situ testing, means the field testing to be conducted. So all these data you will get from the reconnaissance survey. And apart from this, also you may get the existence of settlement cracks in the structure already built near the site. If any structure built near the site, if any cracks are existing or any settlement is existing, you can get the information about those structures. And also sometimes you may get the evidence of landslides or creep of slopes and other shrinkage cracks you may get from the reconnaissance survey. And also you get the location of high flood marks on the nearby buildings and bridges. If any marks are present because of the high flooding over the buildings or the bridges, that also you can note it down. And even the depth of groundwater table as observed in the wells, if it is present near the site, if it is present, then observe the depth of groundwater table or its fluctuations and all by inspecting the site. And even the drainage pattern existing at the site, if any drainage pattern is present, that also you can note it down. And the type of vegetations existing at the site, so that is if the thick forest is present near the site, that also you have to take into account. And this type of vegetation, what it gives the clue to the nature of the soil, what type of soil is present and all, it gives the clue for that. And in addition to making site visits, a geotechnical engineer or the in charge for the subsurface exploration should also study some of the maps. So what are those maps? So he should study the maps also. The geological maps, that is the study of maps from the Survey of India or Geological Survey of India, to get the information regarding faults, folds, cracks, fissures. So these many things he needs to study before taking any major decision. So he should study in reconnaissance only. The geological maps he should study. In that maps he should get the regarding faults, folds, even cracks and fissures. So these kind of maps will be available in the Geological Survey of India. He should get the maps about that site and he should study that one. Even the folds will be like this. So these are the pictures of folds. Should get what type of folds it is, and what are the remedial measures to be taken before constructing the any of the structures about these folds. Even the faults, this is the fault picture, so he should get from the site and also study in detail about these things. And sometimes the aerial photographs also, he should get aerial photography, and topo sheets also. Then the soil maps and the blueprints of the existing buildings. If blueprints are available, that is also taken and studied in detail about the site. And maps and publications of various agencies. If maps are present and if the publications are present, then it will give a lot of information about the geological character of the area. So these all things to be taken into account in a reconnaissance survey. So here the 3 aerial photographs showing the development of an area for housing in one of the site. So this is what the first picture. This picture is a before construction, and the second picture, this one is during construction, and this the last one is the after construction. So this is how we get the aerial photography in a reconnaissance survey. And the geotechnical engineer, even sometimes the satellite images also to be taken into account for the study about site. And the geotechnical engineer should also get the information about the type of structure to be built and its proposed use. And in case of a multi-story buildings, the information about the column loads and their approximate location should also be obtained. And in case of bridges, suppose the bridges are going to propose, then the span length and the load carried by the piers and abutment should be taken into account. And in case of a dam, suppose the dams construction or the dams are to be proposing in a particular site, then the geotechnical engineer or the in charge of subsurface exploration should get information about the type of the dam, its height and base width, and other silent characteristics should be taken into account in a reconnaissance survey. So these all things to be taken into account while doing the reconnaissance. I hope it's clear to you all. My voice is audible to you all.
Yes, sir.
Yes, sir.
Right. This is about the reconnaissance survey in detail, how engineer in charge of subsurface exploration should get the details. So like a map, geological maps or aerial photographs, topo sheets, blueprints, you should study about all things in first step, that is reconnaissance survey. Then coming to the next one, preliminary investigations. Preliminary investigations or preliminary explorations are generally it is in the form of few borings or test pits. Okay, so here what the information you should get in preliminary investigations are to determine the depth and thickness. These are the objectives of the preliminary investigation: to determine the depth, thickness, extent and composition of each stratum at the site. Then second objective is the depth of bedrock and the groundwater table is determined. Then generally in the form of test pits and few borings. As I said, the preliminary investigation goes, generally it is in the form of a test pits, that is a open excavation, or few borings to be done on site to get the more information about the site. And tests are conducted with cone penetrometers. These are some of the equipments which are used to collect the samples, and even sounding rods to obtain the information about the strength and compressibility of the soil. And even geophysical methods are also used for locating the boundaries of different strata. And geophysical methods are the indirect methods without disturbing the soil strata. They will be getting the information about the site, subsurface strata. And this is about the preliminary investigations, and generally it is in the form of, as I said, a few borings or test pits. Okay, so here this is the chart I'm giving here, how the detailed investigation will happen. That is, first in this detailed investigation, first will be the direct method. So in this direct method, it will be in the form of an open excavation is made. Here the in direct method, there are three methods of detailed investigation, that is the direct method, semi-direct method and indirect methods. So in direct methods, it is an open excavation which is made and inspect in the substrata. It is made generally in the form of trial pits or trenches will be done on site. And in semi-direct method, it is, as I said, it is in the form of borings, or the that there is a drilling is being done in a site. And generally the semi-direct method will be of these things, that is auger boring, shell and auger boring, wash boring, percussion drilling, and rotary drilling. Okay, this is a semi-direct method. And indirect methods, they are the geophysical methods and soundings or penetration tests. Again, in the geophysical methods, seismic methods will be used to get the information about the subsurface. And one more is the electrical resistivity method to get the information about the subsurface strata. And sometimes the soundings on penetration tests also used. They are the standard penetration tests and static cone penetration test and dynamic cone penetration test. They are SPT, SCPT, and DCPT. So this is how the detailed investigation goes when you are going to propose any of the construction. A detailed investigation should required as a for an engineer in charge. So the direct method, semi-direct method, and indirect methods. So we'll see one by one what are the direct methods and how the exploration can be done through the direct method. Advantages and disadvantages also will see in one by one. Let us start about the first one, the direct method. So what it means, the direct method. So it's in this method of exploration, an open excavation is made like this. Here the open excavation is made to inspect the substrata, and pits and trenches are excavated like this. Generally the pits and trenches will be like this at the site to inspect the strata, and the size of this pit should be sufficient to provide a necessary working space for the person who is getting the information. And as for IS codal provisions, which recommends a clear working space of 4 feet by 4 feet. So generally a 4 feet by, it is a 4 feet by 4 feet. Okay, 4 feet by 4 feet. So this is as for the codal provision, which should be present, that this much dimensions at the bottom of the pit, and the depth of pit is depends upon the requirement of the investigations, as already discussed. So what kind of investigations you are doing and all, it depends. I mean, how much depth to be taken, or what size of the pit should be present. As per the IS codal provision, the minimum requirement which should be 4 feet by 4 feet. The trench should be taken, and in such inspection, it will be a visual inspection of the soil, and you should get the personal feeling of the soil and collection of the soil samples. And the shallow pits up to a depth of 3 meters can be done. So this type of pits will be up to a depth of 3 meters without providing any lateral support. And if you want to go deeper pits, especially below the groundwater table, lateral support in the form of sheeting and bracing system is required. And even as the depth of pit increases, the cost increases rapidly. So again, it directly depends upon the that cost is directly depends upon the depth of exploration. And for a depth greater than 6 meters, boreholes are more economical than the open pits. So this is just a direct method. You can just take the excavation like this and get the sample and test in the laboratory. Then next, coming to the second method, that is a semi-direct method. They are called as boring methods. As I said, the boring methods, when the depth of exploration is large. So if this direct method is up to 3 meters, is very helpful. Up to 3 meters, we can go for the direct method of just opening the this type of a pit and getting the samples and testing in the laboratory. If suppose the depth of exploration is large, borings are used for the exploration. So a vertical borehole is drilled in the ground. It is a vertical borehole is drilled in the ground to get the information about the subsoil strata. Even the samples are taken from the borehole and tested in a laboratory. Also, the borehole may be used for conducting in situ tests. They are the field tests, and for locating the water tables also these boring methods will be used. And what are the different types of borings will be using? The different types of borings to be used to get the information about the site are auger boring, even wash boring, even rotary drilling, percussion drilling. So such kind of drilling methods will be using. So as I mentioned, different boring methods, as I mentioned, auger boring, wash boring, or rotary drilling boring. And these first three borings will be used for the soft soils, and for percussion boring, and one more is a core boring is there, and the rotary boring is there. They are used for the rock type of stratas. So let us discuss about the first one is the auger boring. So what does it mean and when it will be using? An auger boring is a tool. It's just a tool to one used by the carpenter. You might have seen the carpenter will be using this type of augering for boring holes in a wood. Exactly the same way the boring is to be done in a soil, and it consists of a shank. This part is called the shank part. This middle part is a shank with a cross wire. This is a cross wire. Crosswise handle for turning, and having a central tapered feeder screw. Then the augers can be operated manually as well as mechanically, and these hand operated augers will be very much useful up to 3 to 5 meter depths. And the hand augers used in borings are about 15 to 20 centimeter in diameter. The diameter will be 15 to 20 centimeter generally. These diameters augers, hand operated or manually operated augers, and these are suitable for advancing holes up to 3 meter to 6 meter depth. 3 to 6 meter depth, these are very much useful. 3 to 6 meter depth. And the hand augers is attached to the lower end of the pipe, about 18 millimeter diameter. And next, coming to the mechanical augers, these are called as a mechanical augers. The mechanical augers are driven by power. These are the mechanical augers. These are driven by powers, and these are used for making a holes in a hard strata to get a greater depth. Even for a depths greater than 12 meter, sometimes the mechanical augers become inconvenient, and when they become inconvenient, the other methods of borings are being used. So up to 12 meter depth, these kind of augers will be using. Then auger boring is generally used in soils which can stay open without any casing or drilling mud. Even clays, silts, and partially saturated sands can stand unsupported. And for soils which cannot stand unsupported, especially for sandy soils below water table, a casing is normally required for this one. And for such soils, the method of auger boring becomes very slow and expensive. Then auger boring cannot be used when there are large boulders or other obstructions are present. Then we go for the other types of borings. And auger borings are particularly very useful for a subsurface investigation of highways, even railways and airfields, where the depth of exploration is very small, and the investigations are done quite rapidly and economically by augering. And the main disadvantages of the auger boring is that the soil samples are highly disturbed. Means whatever the soil sample you will be getting through the augering, you may not get the undisturbed sample, you will be getting the disturbed sample. And further, it is very much difficult to locate the exact changes in the soil strata. Means from the Auger boring, you may not be getting the clear information about the strata changing as the depth go on increasing. That is the main disadvantages, or it is I can say it is a very difficult to get the exact information from the Auger boring. So when these are failing to get the or give the more information about the strata, then we go for the indirect methods. They are geophysical methods. So this is what about the auger boring. They are of manually operated and mechanically operated auger borings up to you can say auger boring that is hand operated will be very much useful up to 5 meter or 6 meter depths, and up to 12 meter depth we can go for by using the mechanical or the power driven augers. Okay, so coming to this auger boring only, this is another type of auger boring, shell and auger method you can call. It is quite popular in India. A shell which is also called as a sand baler. So here there is a cell, or it is called as a sand baler, which is nothing but a heavy duty pipe with a cutting edge at the end here, and the length and weight vary according to the requirements. Even the sinker bars are sometimes added to this shell weight, and the rising and dropping of the shell in a hole cuts the soil. This type of shell augering is used to collect the samples of the soil. Here I mentioned the shell used for a soil with the sides of the hole cannot be remain unsupported. Means already a pit is been excavated. So from the pit samples are been collecting through this type of equipment. This is called shell and auger boring. Here a boring is always started first with augering, and shell is used for advancing the borehole. This type of instrument is used for advancing the borehole in the boring. Then the shell raised above the bottom of the hole and allow it to fall freely. Then the impact of the drop when it is fallen from certain height, and because of the impact of the drop cuts the soil and pushes the soil into the tube, and after filling the shell is withdrawn and emptied. This is one type of an equipment which is used to collect the sample. This is called the shell and auger boring. Shell and auger type of boring. So coming to the next type of a boring is a wash boring. So you might have heard in a geotechnical engineering 1 or 2. This is another method in boring, the wash boring. So just it is a drilling inside the soil and getting the soil samples and testing in the laboratory. So what it exactly the means, the wash boring. So this is the instrument picture. So here it is this is a casing. This one is a completely casing part which is inserted inside the soil, and below the casing a drill bit is fixed. Here it is a drill bit. You can observe here drill bit. Then the hollow drill rod is inserted inside the casing. Then continuously water is being pumped inside the hollow casing. Then again it is drilling inside the soil. So generally in wash boring a hole is drilled by first, then by driving the casing about 2 to 3 meter long casing, and then inserting into it a hollow drill rod with a chisel shaped drilling bit at the bottom. Here the drilling bit is provided. This one is a drilling bit. Here can observe here a drilling bit at its lower end, and water is pumped inside. Means the water is pumped in this hollow casing, which is known as a wash pipe. When the water you are allowing to enter into this casing, which is known as the wash pipe, and this water emerges as a strong jet inside the casing through a small opening of the chopping bit. Then the hole is advanced. When the water is entering into this pipe, which will be coming at the bottom of this drilling bit, and the hole is advanced by combination of chopping action and the jetting action. Okay, so here when the water is entered into the soil, then the soil becomes loosened and also becomes soft. And when the jetting action is been taking place because of the water entering into the casing, then here what will happen, as a drilling bit and the accompanying water jet disintegrate the soil, then the water and the chopped soil particles will rise up. Here the chopped particles will rise up because of the pressure what you are providing at the bottom of the bit. Then when the water is rising up between the annular spacing, then the return water, also known as a wash water. So whenever water is being returning through this casing, so which is coming and collecting in this tub here, there is a tub provided here, and this washed water is collecting here, hence it is called as a wash boring. And when it is been collecting water here, washed water, and it will be having a suspended particles in it, and when you leave sometimes for this suspended particles, all that particles will be get settled down, and those will be collected and taking as a samples and testing in the laboratory. And here the for soils which auger boring is not suitable, then we go for the wash boring. And for soils not mixed with the gravels and boulders, where the boulders and gravels are not present, in such situation this wash boring is suitable. And for collecting the samples, replacing the drill bit with the samplers, you can replace the drill bit here to collect the samples. The samples, that is how you can collect, just by taking the that is suspended particles, that is a wash water, to be collected in a tub, and getting the samples and testing those samples in the laboratory. And how you can understand through this method the change of rate of progress and change of color of wash water, means continuously you will getting the water here in the tub. You can notice here, as you are getting the color of the water changing, then you can notice what kind of strata is available below the subsurface. That is, change of rate of progress and change of color of wash water indicate the change in the soil strata. This is what we call as a wash boring. So as I mentioned, the wash boring is commonly used for a boring in a difficult soil. And as I mentioned, to start with the hole, this method, a hole is advanced in a short depth by augering, and then casing pipe is pushed inside just to prevent the sides from caving in, and the hole is then continued here. When the casing is inserted, the hole is continued here. This hole is continued by use of chopping bit fixed at the end of the string of hollow drill rods. Then a stream of water under a pressure is forced. Here water is being injecting inside the casing through the rod and the bit into the hole. What is the use of inserting the water inside here is, which will be loosens the soil as the water flows up around the pipe. Then the loosened soil in suspension, which will be in the suspension form, and that is to be collected in the tub, and that suspension formed water to be taken, and which you can observe that whatever the water you are getting here, that I mentioned here, the change of rate of progress and change of color of wash water, which will be indicating the change in the soil strata. So this is how we get the information from the wash boring. Then coming to the next is a percussion drilling method. What is this percussion drilling method? And this method also the similar type of a wash boring only. But what is the change here? Here the heavy drill bit is suspended from the drill rod or the cable and is driven by the repeated blows. Here repeated blows will be giving, then making the hole inside the soil. But the heavy drill bit is suspended here, This is the arrangement of percussion drilling. This is also one type of wash boring only, but it will be using for what you call as a steep soil or the rock type of strata. If you come across, then this type of method will be using for getting the samples. That is, water is added here also to facilitate the breaking of the steep soil or the rock. And this method is not suitable for loose sand and is slow in plastic clays. So this is about the percussion drilling. So these all methods are used just to collect the samples where augering method fails to give the certain information. Then you have to go for the boring method. So the percussion drilling method is used for making a holes in the rocks, as I said, even boulders and other hard strata. This method will be using. In this method, a heavy chisel is alternatively lifted and dropped in a vertical hole, and the material gets pulverized in this method. The main advantage of percussion drilling method is that it can be used for all types of materials, and it is particularly very useful for drilling holes in glacial tills containing boulders. And one of the major disadvantages of this method is that the material at the bottom of the hole is very much disturbed because of the heavy blows at the bottom. We were giving the heavy blows here. Then it is not possible to get a good quality of undisturbed samples. Further, the method is generally more expensive. This type of a method is more expensive than any other methods. Then also it becomes very much difficult to detect minor changes in the properties of the strata penetrated. Means if anything changes below the strata, it is very much difficult to identify. So these are the some drawbacks of this percussion drilling method. And basically this method will be using for the rocks and boulders. Again, this it is the same method what we discussed previous. There is a wash boring only, but this is used for rocks and boulders type of a strata. And also it is not suitable for loose sand and is very much slow in plastic clays. And drawback is it is very much expensive. And here you will be getting undisturbed sample, and you may not get the disturbed sample. You may not get the undisturbed sample here. These are the percussion drilling tools which are used to make a boring in a soil strata. These are just tools to used or to collect the samples. Coming to the next one is a rotary drilling. This is also a same type what we have discussed previously. In rotary drilling method, a borehole is advanced by rotating a hollow drill rod which has a cutting bit at the lower end. A drill head is provided at the top of the drill rod here. A drill head is provided, and it consists of a rotary mechanism and an arrangement for applying a downward pressure. It will be having a rotary mechanism, also an arrangement for applying the downward pressure. And as the drilling rod is rotated here in this method, the drilling rod is rotated here. A drilling rod is rotated. The cutting bit which will be shears off the chips of the material penetrated, and a drilling fluid under the pressure is introduced through the drilling rod to the bottom of the hole, and the fluid carries cuttings of the material which are penetrated from the bottom of the hole to the ground surface through the annular space between the drilling rod and the walls of the hole. Even the drilling fluid is also used to cool the drilling bit, and this is very much useful in rocks. That is fast in rocks, and drill bit is fixed to the lower end of the drill rod, is rotated by the power. Then sometimes a bentonite slurry is also used, which is forced under a pressure through the drill rod, and it comes up along with the cutting soil. And rock cores can be obtained by using a suitable diamond drill bits. Means the diamond drill bits is also used to cut the rocks and all. and it is very much useful for the rock strata. This is the rotary type of a drilling method. And even here, when the soil sample is required to be taken, the drilling rod is raised and drilling bit is replaced by the sampler. And this rotary drilling can be used in clay, sand and rocks also. And the boreholes of diameter 50 millimeter to 200 millimeter can be easily made by this method. And this method is not well adapted for use in materials containing large percentage of particles of gravel size, that is gravel size and larger. The particles of size, that is the particles of this size start rotating beneath the drill rod, and it becomes very much difficult to advance the hole. Okay, so this is about the rotary drilling method. Just to remember, this is used for the rock type of a strata, and just it is rotating inside the soil strata. Then bit will be using diamond bit or other types of a bit will be using just to get the samples from the rock strata. So this is how the methods are being using to get the more information about the soil strata. These are the some methods are discussed here. They are the auger methods, they are hand augering or the mechanical augering, or the wash borings, where the augering method fails to give the information about the subsoil strata. Then these borings will be using, that is wash borings. Then percussion drilling methods and rotary drilling methods will be using to get the information about the subsoil strata. And some methods are very much useful for the some soft soils, and some methods are very much useful for the rock type of stratas, or clays type of stratas, or sandy type of stratas. So each methods will be having their own significance, and as a soil in charge or the geotechnical engineer, he should know what method is to be used to get the information of the about the soil strata and all. Just these are the some methods I discussed to get the samples from the site, and after getting the samples through these methods, and those samples to be collected and testing in the laboratory, or sometimes you may test in a field also. From the laboratory you may get the engineering properties of the soil, the grain size, the shrinkage limit, plasticity limit, water content, and SBC of the soil you may get. And even from the field test also, the vein shear test is there, and also some plate load tests are there, penetration tests are there, that also can be done on site if required as by the in charge engineer. So these are the some investigations what we do in a site by getting the information about the site, and also getting the samples and testing in the laboratory. So today I discussed about the direct method. It is just an open excavation method, and there is a trial pits and trenches, and getting the samples and testing in the laboratory. Then the semi-direct methods, that is the boring methods. Then that in the boring methods, the auger boring, shell and auger boring, wash boring, percussion drilling methods, and rotary drilling methods. So these methods are discussed in this today's class. So next, coming to the indirect methods, where you required again the more informations, where you don't want to disturb the soil strata. So these semi-direct methods or the direct methods are what? So you are making the hole inside the soil and getting the information, but without making any holes, directly you are getting the information about the strata. That what we call as a indirect methods. They are geophysical methods. In geophysical method, again the seismic method and electrical resistivity method, and one more is a sounding or a penetration tests. In again the sounding and penetration tests, the standard penetration test is there, SCPT test is there, that is static cone penetration test is there, and dynamic cone penetration test is there. Okay, so these methods again we'll discuss in the next session. So about the indirect methods, but they are in your syllabus, they are clearly mentioned indirect methods of testing the soil. They are geophysical methods or geophysical methods of exploration. They are seismic method and electrical resistivity method. Two methods are very much important for getting the more information about the substrata. And these are the very much important for the examination point of view. Many a times the question will be there for the geophysical methods. You can make a note of it. These two methods are very much important for the examination point of view. They may ask explain about the geophysical methods, then you may explain about the seismic method and electrical resistivity method. So other is the sounding or a penetration tests, that is a SPT test or SCPT test and DCPT test. Okay.